Let's examine how the experimental evidence leads to us invoking a concerted migration step. Firstly, when the alpha carbon is a chiral center, the reaction results in retention of configuration at that carbon. Secondly, the more substituted alpha carbon migrates faster and the reaction is regioselective. Both of these observations agree with a concerted migration step. The electron withdrawing acetyl group on the OO bond is pulling electrons towards itself. So it makes sense that the more electron-rich side of the substrate should migrate faster, and this accounts for the observed regioselectivity. The stereospecificity, where the configuration of the migrating group is retained, also backs up the concerted nature of this process. The alternative is a stepwise series of events in which a radical, carbocation, or carbanion is formed by the carbocycle opening up. Such events would result in a planar species in which the stereochemistry at the alpha carbon would be lost. Hence, a concerted migration step is most likely to be occurring. Additional examples of the Baeyer Villiger reaction are shown here. In the first one, the reaction is regioselective since the stronger electron-donating alpha carbon has migrated. Since there isn't a chiral carbon in the starting ketone, there is no stereochemistry to be concerned with here. For the second example, the reaction is again observed to be regioselective, with the more electron-donating aromatic ring migrating faster. In the third example, the reaction is regioselective, with the more substituted alpha carbon more likely to migrate. It is also stereospecific, with the configuration of the migrating group being retained. The Baeyer Villiger oxidation is a very mild and convenient method for converting ketones into esters through transfer of oxygen from a peroxy acid.